Alright, looks like we're live. Hello and welcome everyone to yet another Zozin session where we continue developing our programming language called Porth. Before we start, I need to make a little bit of an announcement on our Discord server, super quick. And let's go over. So what are we doing today? So today we're making a programming language, the same thing we do every programming session these days, just developing our own programming language. Hello, Membrilla Amarilla, welcome to the stream. Hello. So red circle live on Twitch, and yeah, making programming language, and I'm gonna give the link to the Twitch, twitch.tv/Zozin, pinged. And there we go, we're live. Hello everyone, really glad to see you all today. What the fuck is wrong with me? I don't know. So, you can find the source code of this language in the chat if you're watching live, or in the description if you're watching on YouTube. So let's take a look at what we've got. As far as I know, in the previous session, we were working on static typing, and we implemented a static typing for simple intrinsics, right? So intrinsics that basically take you know, some arguments from the stack and put the result on the stack. But we didn't do anything special for control flow, which are a little bit tricky. And this is what I wanted to focus on today. I wanted to focus on finishing the type checking and implementing the type checking specifically for control flow, because the type checking control flow is actually very special and also very important. So majority of the mistakes are going to be caught somewhere inside of the control flow. Hello Edis C, Dava Wen, M Alkali, Pepper 3R, Carrot 91. Hello, welcome guys. How are you guys doing? So let's take a look at what we've got. So I did a little bit of a development off screen, so some boring parts and stuff like that. And let me go to the master. Check out master. Hello everyone. Let's fetch origin master and super quick. Prune. I wanted to do prune actually. Hi, I'm here for Haskell from Haskell rank, which helped me a lot and was great for motivation. Huge thanks. Let's hope I pass Haskell exam tomorrow. Well, good luck on your exam. Good luck on your exam tomorrow. Haskell is in fact a very fun programming language, not gonna lie. Prototype 04, I hope I'm pronouncing the name correctly. Thank you so much for tier 1 subscription, your first subscription by the way, and welcome to our epic Porth club. How about that? So Haskell exam, I never thought about that being a thing. In fact, Haskell itself comes from academia environment, and it's taught in universities quite often all around the world, and including Russia. As far as I know, there is like quite a few universities even in Russia that actually teach Haskell to the students. Unfortunately, it was not my university, but something like Moscow State University, I know, like I heard people reporting that they do study Haskell in there as part of their functional programming course or something like that. So yeah, people do study Haskell in universities quite often, like all around the world. It is a thing. It is in fact a thing. Together with Prolog, yes, exactly, together with Prolog. And what's interesting is that in my university we did study Prolog, but we didn't study Haskell, unfortunately. And at the time when we were studying Prolog, I was a huge fan of Haskell, and I was so upset that they didn't study Haskell. We didn't study Haskell, and it is what it is, and it isn't what it isn't. Anyway, so let's take a look at what we've done in the previous streams. As I already mentioned in previous streams, we started developing the static type system, and let's see how well it performs on simple things, right? For instance, one of the things you can do is sum up two numbers, right? This is not how we sum up numbers in this language. You first have to push them to the stack, and then you have to perform plus, which will sum up the things, and then you have to print it, right? So what's interesting is that you can right now interpret it as you want, right? And what's interesting is that if you remove print, the program will still work, right? But according to our static type checking model, this should not compile, because according to that model, you have to handle everything on the stack. So if by the end of the compilation of the program, you have something on the stack, this is an error, and you have to explicitly drop that thing from the stack or print it. So the reason why it didn't complain is because type checking, static type checking, is not enabled by default, right? Because it's not finished yet. So it's optional right now. To enable it, you have to put a flag check, and now it will complain about unhandled data on the stack, right? It will tell you that, so this operation produced some data that you didn't handle. You have to drop that data, right? Or you have to print it, because print also consumes that data, and that will compile. Right, so on top of that, you can have situations when you don't have enough data for the plus operation, and that is also a compilation error, right? It will say not enough arguments for the plus intrinsic. So you see, it catches these kind of errors. And quite often there was a situation when an error happens inside of a macro, and off screen I implemented basically reporting the expansion stacks of the macros. So let me show you what I mean. If you include the standard library, in the standard library we have a macro called write, right? And write essentially a wrapper around the syscall, the Linux syscall write. So let's take a look at it. So if you go into the standard library and you take a look at the macro write, as you can see, it's just a syscall to write, nothing special, right? And quite often, if you do hello world using this thing, hello world, and you will put that to std out, this thing won't compile, because write also produces the return code. Each individual syscall produces a return code that you have to handle or drop, right? And because of that, it will always fail, but it would fail inside of the standard library, and you won't be able to know where exactly in your program that thing failed, because it went through a series of expansions, right? It went through a series of expansion, and it's unclear where exactly is the problem. Right now, we actually print the sort of expansion stack, and now you can see that the problem actually happened in here. In fact, you can actually do something like macro hello, right? And you can put that thing inside of a macro, and then put hello in here, and it will expand the stack. So as you can see, unhanded data on the stack, and it was expanded in here, and it was expanded in here. So as you can see, you have like this stack that you can follow and see where precisely this entire thing has failed. So, which is rather convenient. So I decided to do that off screen because there's nothing particularly interesting in implementing that. You just like keep track of the locations, yeah. Type checking control flow, like ifs and while loops, is actually way more interesting, and this is precisely why I decided to actually stream that. So let's take a look. So ifs and while loops, they usually look like this. Let's take a look at them. So so the source code is dead. Oh yeah, I see what you guys talking about. I'm really sorry about that. Just a second. Coppercasted, thank you so much for 25 months of tier 1 subscription. Hello, welcome to the stream. Update CMD or this one is going to be 1 sender, and this is supposed to be Porth. Right, so, and if you just want a link, you can just do a Porth command. It will also give you a link. All right, thank you so much for letting me know that there's a problem with the project command. Hello everyone, hello everyone who just joined. Welcome. So, okay. So I have a couple of tests that test different parts of the functionality of the language. Like for instance, arithmetics, right? And if we try to run the arithmetics test, so I'm going to try to simulate this entire thing. So this is going to be arithmetics. and it runs, and then I can try to type check it, and it also type checks. There is nothing particularly special in here. So the thing that won't type check is the control flow, right? We have a test called control flow, and if we even take a look at it, control flow, we'll see things like if conditions and while loops, and for if conditions and while loops we don't have any type checking implemented, and as you can see it will crash somewhere inside of the source code on if operation saying that it's not implemented, right? Saying that it's not implemented. And the question is how you're supposed to implement type checking for control flow, right? So in case of the simple intrinsics that consume something on the stack and push back something on the stack, essentially you perform some sort of a meta evaluation, pushing on the stack not the values but rather the types, and basically comparing the expected types. Pretty straightforward. But in case of an if, it's rather unclear what you're supposed to do. Right, so let's take a look at a simple example. So you have some code, like right before the if. Then you have some sort of a condition, right? You have a condition, and then you have an if operation. Let's actually enable Porth mode. Right? Here's the if operation. The thing about if operation is that it consumes a boolean at the top of the stack, a single boolean at the top of the stack, and then it performs the body if it is true, and if it is false, it skips the body of the if, continue executing the code, right? So this is basically how it works, right? So we have some code in here, then it checks the condition and then performs the body or doesn't perform the body. We can easily type check the fact that if consumes the condition. But then how do we type check the body? How do we type check the body? So here's my thought on how to type check the body. So essentially, the body in elseless if, so we're looking at elseless if, because if with else is slightly different. So the body should not change the state of the stack. So every time we execute a line, the state of the stack changes, right? So this each individual line in here changes the state of the stack. So after we executed the body, here the state of the stack should stay as it was before the body, right? So it may modify here in the future, but the last line, or like the sequence of lines, should bring it back to S3. It should bring back to S3, and at this point it has to be S3. Right. The reason why the body shouldn't modify the state of the stack is because the code after if doesn't know if the condition was true or false. Right, if it, so basically this body, this sequence of code expects the stack to be in state S3, right? So, and it wants the state to be in S3 regardless of whether this condition was true or false, right? So it has to be in S3, because for this code there is no way to differentiate whether the condition was true or false. Does it make sense? So, because I think this is how you have to handle specifically elseless if. Right. But what if you do want to change the stack with the condition? So what exactly do you want to do there? What exactly do you want to do? So by changing the stack, I actually mean change the types of the elements. Only the types of the elements. The elements themselves can be different. So the only thing that is not allowed to change is the types, right? Because then consequence instructions expect specific types after the body of the if, regardless of whether the condition was true or false. Does that make any sense? Right. So I'm talking specifically about the types of the elements, but not the elements themselves, not the values. So only the types. So, and if the types have changed, or you have more data or less data, the program won't type check at the end anyway. Right, it won't type check anyway. Okay, it makes sense. Okay, I'm really glad that. So, and how can we even do that? So we need to somehow save the state of the stack to compare it to like when we reach the end of if or something. So yeah, anyway, let's actually start implementing the if. Let's start implementing the if and we'll see what we have in there. So when we encounter if, we need to check that we have enough arguments, right? If the size of the stack is less than 1, we'll say not enough arguments for a particular intrinsic. So I still call it intrinsic surprisingly, so which is not correct. So yeah, I have a special helper that reports errors if you don't have enough arguments for the intrinsic. So I think now I need to change this helper to actually report like not enough arguments for operation, right? Because sometimes you may not want to have an intrinsic. So let's say not enough arguments. And the question is, how should we report this kind of stuff? So, hello everyone who just joined. We can maybe accept an operation, right? Because intrinsic is an operation, right? So in here we can do if the type of the operation is equal to intrinsic, right? So if this thing is intrinsic, we're going to report it like this, not enough argument for this intrinsic, and then I can just use operand, and because intrinsic is stored in the operand of the operation. I could do hello. Right, otherwise we're going to report a different compiler error. Right, so this one is going to be not enough arguments for the So I'm not sure about the other things. So as far as I know, OP type if so maybe we're going to say else if OP type if, right, not enough arguments for the if block, right, for the if block, and that is going to be it, I suppose, right, and this one is going to be something else. And what's interesting is that I think we're going to have a similar not enough arguments error for while as well. Not really while, but for the do. But I'm not 100% sure, so I'm going to actually do something like false and mark it as unreachable. So maybe it's not really unreachable because it is reachable, unsupported type of operation, right? Unsupported type of operation. Okay, so and in here I want to do a little bit of a type checkings, right? So just to check if everything's okay and in how many places this entire thing will fail. All right, so what is it complaining about? Invalid index type for Kozak Polv, I hope I pronounce your nickname correctly. Thank you so much for tier 1 subscription, your first subscription by the way, and welcome to our epic Porth club. So operand for some reason doesn't really work properly. Invalid index type union intrinsic. I see. So because operand is a union of these 4 things, so at this point the MyPy doesn't know that it might be intrinsic, so we have to assert something, right? So we need to assert that the OP operand, right? OP operand is instance of intrinsic, right? And if it is not, there is some sort of a mistake in here. Okay, so and in here what I want to do is essentially I actually want to... Oh shit, look at that. So we are providing the token as the location where we have to report an error. And we're also providing an operand. But we recently made a change, right? So as the second argument is an operand. So, but operand itself contains the token that we provide as the location, which means that we don't really need a location anymore because we can just get that location from the operand itself. Right, so this is actually pretty cool. It's a token, right? So it simplifies everything. So we only have to provide the operation itself. Only Slavic people pronounce my nick correctly first time, lol. Did I pronounce it correctly though? Kozak Polv. Kikumurt. Alright, so now one of the things I want you to do, in fact, I also want you to do a little bit of a magical refactoring, right? I want you to replace this thing with something else. I can't shit, I can see shit in this mist. I can mist shit in this. I don't know how to say that, I'm sorry. I'm an idiot. Don't copy-paste code, kids. So I'm a trained professional, I know what I'm doing, but don't copy-paste code. Okay. And here we have another thing, so not enough arguments, right? Not enough arguments for this specific thing, and then I can just say exit 1. Perfect. There we go. So, and everything seems to be actually compiling properly. So after we checked that we have at least one argument on the stack, we want to actually pop that argument from the stack, right? It's so strange for some reason to see grammar parser implementation in Python. Do you have any plans converting it to Yak Bison and Lex Flex in the future maybe? No, I don't have any plans to convert them to these things in the future because the grammar of this language is so simple that the complexity that additional tools add to the projects are just not worth it. So yeah. So you have to understand that right now the language is implemented in one language. There's only one language and one tool. It's called Python. By introducing Lex or Bison, we're introducing two tools, basically introducing two additional moving parts to the whole build system. Right now, there is no such moving parts, and the entire build system is actually super simple. There is no build system. But if we introduce something like that, we will have to introduce a build step, which will complicate the maintenance. And you have to evaluate properly, is it worth it? For such a simple syntax, it's just not. And it probably never will be for such a language. Maybe there are situations when it is in fact worth it, but for this specific project, it's just not. It's as simple as that. All right. So, and on the stack, as far as I know, we have data type and the token where exactly that data type was introduced. Deep Singularity, hello, welcome to the stream. So, and here I suppose we'll have to do something like a token and then a type. I think it's the other way around. It's a type and a token. Right, and then we can check if a type is not equal to data type boolean. That means we did a fucky wacky and maybe possibly oopsie doopsie. So let's do a compiler error. So compiler error, and where exactly we're going to do the compiler error? This is an interesting question. So where do we usually do that? We do that on OP token, so on the token itself, on the operation itself. Right, so that means we'll have to do something like this. Invalid argument for the if block condition, expected boolean, right? Expected boolean, and after that we're gonna exit this entire thing. There we go. And I suppose that is basically it for now. So maybe I'm gonna just remove this not implemented and see how it's gonna go. So let me see. So I want to go to the tests, right? I want to go to the tests and take a look at the control flow. I'm going to comment out while for now, so it does not distract us. And let's try to simply run my Porth. Right, compiler error is not defined already. It has underscore. I haven't removed underscore, so I use underscore for refactoring purposes, but then I forgot to remove it at some point, so it doesn't really matter that much. Tests, control flow, right, so control flow Porth. And it runs, but does a type check. Let's see. Okay, so it doesn't type check, but this is because we haven't implemented else yet. Which is rather interesting. So we're not doing ifs with else. So I suppose I'll have to craft a different example in here. Okay, so what we're gonna do, I'm going to include the standard library. std Porth. So here we're gonna have something like this, and if this entire thing is, you know, if 0 is less than 10, we're going to maybe, I don't know, maybe we're gonna put 10, right, put 10, and then we're gonna print this entire thing, right? So we have 20, then we push 2 additional things in here and then compare them, then we push additional thing, and then we print it. So as far as I know, this code should not compile. This code should not compile, and it fails because we don't have, well, I mean, I rerun this entire thing, so I should probably run something like this. So it should fail at end. There we go. So we implemented type checking for if, but we didn't implement the type checking for end, right? So, and what's interesting is that and may close not only if blocks, but it can also close while blocks. So we need to somehow differentiate what block it's currently closing. Right, so let's actually introduce an interesting thing. As I already said, the if should not modify the current state of the stack. To know whether we modify the current state of the stack or not, we need to save the current state of the stack. Right? So let's introduce a way to actually snapshot the current state of the stack, right? So the stack is located in here. So here is the stack. So maybe I'm going to introduce like a type alias in here, right? So this is going to be data stack, right? So this is a data stack, and it's a list of tuples of pairs, data type, and a token that introduced that data type on the stack, right? So, and the stack is going to be the data stack, right? And let's introduce something like snapshots, maybe stack snapshots. And it's going to be a list of data stacks, right? Maybe there is a more efficient way of implementing this thing, but I cannot think of one, right? So I cannot think of anything simpler than just like taking literally the entire stack, the entire current stack, copying it and putting it on into the list of snapshots. Right, so I think that's basically what we want to do in here. So let's go to the if part, right, and after we checked everything, we're going to do something like snapshots, stack snapshots, right? Did I call stack snapshots? And I'm going to append the copy of the current stack. Memory usage go, I mean, we are in 2021. We are in 2021, memory is cheap. Come on. I'm pretty sure I'm going to even implement that this feature this way even when we rewrite in Porth. And Porth doesn't have a garbage collector, and I'm not going to even care. Right. To be fair, for the Porth, I plan to implement like a very simple custom allocator for different kinds of objects, because we have a fixed amount of objects in here. We have such objects as token, operation, and macro, and all of them are like a small fixed size objects. And for them, I can easily implement like separate arenas. And that way, I think this is the way we're going to manage the memory in Porth, right? So it's going to be just basically several arenas for different kinds of objects. And there's not that many objects in here that we need to allocate and deallocate all the time. So, Anyways, so we make a copy, and there we go. So when we encounter the end, the first thing we're gonna do, we're gonna actually pop the snapshot, right? We're popping the snapshot. So this is gonna be stack, snapshot, and we're just popping it. But here's an interesting thing. Again, end may end several different blocks, right? It ends if, and it ends else, and it also ends while. So we also need to keep track of what block is currently opened. So because of that, the snapshots should not only contain the data stacks, they should also contain the type of the operation, right, that actually started the block. So let's actually do something like this. This is going to be list of a tuple, right? And the first element of the tuple is the data stack, and the second one is going to be operation type. What's the operation that opened the block? It's more of a, like, it's not really even a snapshot, it's a block stack, right? So, and here we store the state of the stack when the block started and what operation started the block. So that's basically what it is. It's a block stack. So the first one is the current data stack, and also we have a block stack. So snapshots, block stack, snapshots. Maybe I'm gonna call it snapshots, and this one is gonna be block stack. So, and here we have a snapshot. Maybe I'm gonna call it block. I think I know what I'm going to call it. I'm going to call it expected stack, right? So this is an expected stack, and block operation, right? So this is a block OP, or maybe block type. Yeah, I think it's going to be something like this. And again, AND may actually end several of these things. So right now we only care about operation type if. And by the way, here I should probably put something like OP type. There we go. So if we have if, we're gonna say that this entire thing is not implemented, right? Not implemented. So what is the other kind of block that this thing may close? I think the other one is going to be the else, right? So we may close else. Emacs. What the hell are you doing, Emacs? So false, not implemented, right? Not implemented. If block type, OP type. So what's going to be the next thing? So it may close if, it may close else, and it may close while, or not. I think, yeah, it doesn't close while, it closes do, right? Because the while block is while condition, right? While condition do, and end doesn't really close this the while, it closes the do, right? So it's like a 3 keyword block. All right, so this one. Emacs, why are you so annoying? So this one is assert, this one is not implemented. Right, and in here we're gonna say that this thing is unreachable, right? And again, if we add a new kind of operation, I think we should definitely visit this this piece of code, right? So that means I'm gonna assert the length of OP type, and I would expect it to be 8, right? Exhaustive handling of OP types, just OP types, there we go. Exhaustive handling of OP types, and I think that is it. Let me see if it fails in a place where I expect it to fail. Okay, there we go. So this is actually perfect. Okay, cool. We have expected stack and we have a block type, and here we actually reached the end. So that means we need to only assert if the expected stack is equal to the current stack. Because once we reached this place, we essentially reached this thing, right? We know the current state of the stack after we checked this body, and we know what kind of state of stack we expect because we saved it. So the only thing we need to know now is to do to compare them. Does it make sense? So we just need to compare them. So there we go. But what's interesting is that so this stack, the data stack, contains not only types, it also contains the tokens. And the tokens that introduce different kind of types, like they may change. The only thing that shouldn't change is the types of those things, right? So I think before we compare those things, we have to strip off the tokens off of the data stacks. So this is one of the things we have to do. All right, so how can we do that? I suppose we can just map expected stack lambda. So this is the element, and we have to do what? Wait a second. So where's the definition of data stack? So the data stack is, so we need to only take the first element from here. So it has to be x0. There we go. And after that, I suppose we also want to convert that to a list, and that gives us basically a sequence of types, right? And we want to do the same with the stack itself, right? So with the current stack. So it's going to be x0, and this is the stack, and then we're going to also convert it to a list. And if this condition is false, right, if they're not equal, that means the if condition altered the types on the stack, and something went horribly wrong. If else can alter the stack, but it has to do the same in both branches, isn't it? Yes, you got it right. So essentially the idea is the following. If doesn't have else, it is not allowed to change the types of the stack. If it changes the else, it may do that, but it has to do that in both of the branches, right? So you got it completely right. So, all right, so if the types have changed, we have to report this entire thing. We have to report it. So compiler error, and where error has happened, I suppose we can say that the error has happened at the token of the current operation, right, at the end, and we have to say something, something like if else less if block is not allowed to modify the arguments, the types, not really modify, but to alter the types of the arguments on the data stack. And it would be also kind of cool to basically show the difference, right? Somehow show the difference, right? So here is the types of one thing, and here is the type of another thing. But I'm just afraid that maybe it's going to be too long, and I'm not sure if I want to show everything. We can try to show everything. Okay, so let's actually do it like this. Compiler note, this one is going to be note, and the note is going to be the following. Something like expected types is going to be something like this, right? And we're going to put this thing in here. So let's actually do something like this. Expected types, I would even say, right? So this is expected types, and this is actual types, and we're going to save those things to separate variables. Expected types, and this one is actual types. So expected types is going to be reported here, expected types, and then we're going to have actual types. Actual types, and after that we're of course going to just, you know, break this entire thing. Cool. All right, so let's go ahead and do that. Okay, it instantly reported the thing. Elseless if block is not allowed to alter the types of the arguments on the stack. Expected types int, actual types int. So if we take a look at this thing, so the current state of the stack was like one int, but then we added another thing to the stack, and yeah, so this is not allowed. What you have to do in here, you have to either drop this 10 or print it. right? You have to print it. So, and after that, only after that, this thing will work, right? And the reason why it should be like that is because when the condition is actually false, the code still should work properly. It still should type check. And if it's, you know, if it's allowed, you can create a situation when it's not going to be type checked, right? There we go. So actually we fixed the thing in here. I think it's pretty cool. What do you guys think? So yeah, there we go. Elseless if block is not allowed to alter the types of the arguments on the data stack. So we have an actual type checking for elseless ifs. We don't have a type checking for ifs with else, but we are about to introduce one. Does anyone have any questions so far about what we just did? Is this language as fast as Jai? I have no idea because Jai doesn't exist. Thinking of what to put on GitHub to get trusted on those in server. I currently have nothing on GitHub. Yeah, okay. So we recently introduced a policy on our Discord server. If you're watching on YouTube and you want to join our Discord server, so by default, it's read only. But if you attach your GitHub profile and I'll look into that profile and you have something that you've done yourself, you may receive a voice on the server. So I think it's a pretty good idea because I heard a lot of people say that they don't want to put anything on GitHub because they're shy and stuff like that. And now you have an incentive to finally put something on GitHub, to finally clean up your GitHub profile, right? If you do so, you have an opportunity to receive a voice in an epic sodding server, right? Hello, Sinduri2Worm. So I can create something dumb and I get access? Well, I guess, well, it has to be something creative, I suppose. I mean, just something like tangible, right? Some sort of like, I don't know, URL shortener, right, that you made in PHP. I would give a trusted for that, right? If you actually sat down and coded yourself a URL shortener in PHP, I unironically will give you trusted for that because this is something that you've done yourself, right? It's your thing, you made it. And I do respect people who make things, right? Regardless of the language, regardless of the technology, you made something working that actually works, and that deserves a respect, right? So, yeah, so things like that. Does it have to be specific language? No, it doesn't have to be in any specific language. It has to be like a thing, like actual thing, you know, that you've done yourself and it actually works, right? A software thing, a software product, I would say. The language doesn't matter. Like, I don't care about the languages. Okay. So. Okay, so let's actually commit whatever we have and start working on else, right? Start working on else. I just stopped caring about people's opinion on my code. My main baby violates a lot of Python conventions. Do you think I care about Python conventions? Do you think I care about them? Look at this beauty. Look at it. It's so beautiful. People are mad by looking at this code, like, holy shit. And I love that. Anyway, so it doesn't matter, people, you don't understand. It doesn't matter. The only thing that matters is that your code works and it does the thing it's supposed to do. That's what matters. Okay? At the end of the day, nobody's gonna look into your code, right? So the most popular software projects usually have the most horrible code that you can possibly imagine, seriously. To the point that I'm starting to believe that there's no such thing as useful and pretty code simultaneously. I've never seen one. I'm programming for more than 15 years and I've never seen a useful and a predicate at the same time. Seriously. Usually, like an actually useful code is pretty goddamn dirty because the reality is pretty goddamn dirty, right? Because the useful code has to deal with the reality and reality is ugly. And it is what it is and it isn't what it isn't. You can be mad about it and you can try to prove me wrong how much you want. It is what it is. It doesn't change the reality. Okay. So, though I do agree that that my code, despite of the reality, could have been better. I do agree with that. But here is the thing. Like, you can improve this code and make it more readable and stuff like that. But I don't want to do that because I do plan to rewrite it anyway. Right. If I focus too much on the prettiness of this code, I will postpone the time when I will start finally rewriting it in Porth and getting rid of Python. So the only reason why this code is kind of sloppy is because I just literally don't care. Right. Because it's going to be gone anyway. So what's the point of making something pretty that you're going to remove anyway? So, yeah. Anyway. Let's continue. So I think I want to create a separate branch, right? So the first thing I need to do, type check control flow, right? Type check control flow. So implement type checking for else less if, right? So else less if. I'm going to push that right into the read. But my Haskell, actually, ironically, the most like dirtiest and ugliest code I've ever seen was probably the Haskell code. Because the more you need to interact with the real world in Haskell, the more you have to hack the Haskell. The more you have to go against the Haskell ideology, right? And actually useful code in Haskell is goddamn ugly, like holy shit, right? Because actually useful things in Haskell go against this entire ideology of like pure functions and immutable states, and it's just like holy fuck. So anyway. So we need to start working on else, right? So let me try. So it's gonna be Porth, and we're gonna try to simulate the control flow, right? So this is gonna be the control flow. It seems to be okay. So I forgot to do a check. There we go. So now it says not implemented, but it says on else. Okay, so we reached the else block. All right, we reached the else. How are we going to type check this entire thing? Control flow. So in here, the only thing we know is that the block starts at if and the current state of the thing. So I suppose what we have to do if we encounter else, we have to throw away whatever is expected stack right now, take the new current stack and push it and continue executing until we reach the end. Yes, that's basically what we have to do, essentially. Yeah, okay, let me take a look. So this is going to be the Porth, right? So this is going to be the Porth, and if we encounter else, to be fair, we don't really even have to check expected and actual types. What we have to do is take the stack and push it back. So we have to do block stack, append, copy, stack. It's interesting. Where exactly did it fail? I would expect it to actually fail somewhere here. Right, it failed somewhere at the end, and that is kind of sus, not gonna lie. Oh yeah, it failed actually here, so it's just like me being silly thinking that it actually failed in here. Okay, so that seems to be fine. That seems to be fine. Alright, so in here I want to take the expected stack. So I'm taking the expected stack and the block type, right? Block stack pop. So an interesting thing is that if everything implemented correctly, the compilation step is implemented correctly, and the code above is implemented correctly, the block type must be, it must be OP type if. And if it is not, it is a bug somewhere in implementation in the code. So it's never like, this may not happen because of the user input, right? This situation may not happen because of the user input. If user provided malformed import, we don't even reach this place at all. The error will be reported even before this place. If we somehow reach this place, it's a bug in a place that is supposed to report an error, right? So you see what I'm talking about? So that's why this is an assertion, right? We should never reach this place. But if we do, something went wrong and we did a fucky wacky, oopsie doopsie, uwu, you know, the usual stuff. So expected stack. So if we encounter this thing, so that means I have to do block stack, and we're gonna append the new data stack, right? So this is gonna be that, and this one is gonna be just OP type. There we go. So we're basically throwing away this thing, right? Because it's not needed. We have in fact an if with else, not elseless if, right? So what's the next place where it's gonna fail? So it fails at the end, right? So we reach the end, and now now we need to do what? Now we need to, oh boy, oh shit, this one is interesting actually. Fuck. Right, so let's take a look. So now you have else in here, right? Right, so here we have this situation. So we modify to the state S3, then we go inside of if and modify to the state of S6. Right, but then after we reached else, we have to roll back to S3 and continue evaluating to S, you know, 7, S8, and back to S3, back to S6. Right, so when we encounter else, we not only save S6, we also roll back the current stack back to its original form. So, yeah. So if I want to have a voice on Discord, I have to DM you there. Check out the rules channel, right? Check out the rules channels. One of the things you have to do is to subscribe to Twitch channel, and you should get the voice automatically. If you don't get the voice automatically, Google up how to link your Twitch account with your Discord account. Once you link them together, you will get a voice automatically. Since you're a subscriber, you don't have to do anything, right? So you just link your Twitch account and that's it. So, and what's interesting is that it's relatively straightforward to roll back. So essentially we have to roll back in here, right? So this is a stack snapshot. And what's the easiest way to roll back there? That's a good question. What's the easiest way to roll back? Well, I don't know, we can try to literally do something like that, right? So essentially, yeah, that's the way to go, I suppose. Why not? I guess we can do it like that. That kind of alters the tokens, I suppose. Well, not really. Not really. I guess it's fine. Where did you study this? Believe it or not, on Twitch. A lot of things I know, I actually learned by streaming them on Twitch. All right, so I guess this is how we do that. So we roll back, and once we go to else, right, once we go to else, we essentially just need to compare the actual, the expected types with the actual types. And since we need to do that in a second block in here, I might as well actually like hoist these things. I really like the word hoist. So, and here we can check something, right? So expected types, and all right. So this is going to be compiler error, right? So OP token. So if block, then both branches of the if block must produce the same types of the arguments, on the data stack, right? And I can do this thing. So here is expected stuff, and here is actual stuff, and then I'm gonna exit with one, right? If something like this, you know, didn't type check, well, ooh, oopsie doopsie, and fucky wacky, the usual stuff, right? Okay, unhandled data on the stack. So it complains about unhandled data on the stack. Okay, this is really useful. You see, it actually says here that, right, for the right, you have unhandled data on the stack. So if I drop this thing, now it works. Okay, let's actually try to make like if fail somewhere, right? I can do something like that, and as you can see, both branches of the if block must produce the same type of the arguments, right? Here, expected types none, but the actual types something. So as you can see, this one produced none of the argument, and this one produced one, which actually leads me to a very interesting question, right? What if I remove both of the prints from the if? That if will kind of work, but now you have unhandled data from that if. Oh, the type system actually led me to a pretty cool refactoring where I can just move prints out of the if. Holy shit. So I didn't even finish this feature, it's already useful. Holy fuck. What the fuck? Oh my god, I really like that. I really like the fact that when I don't handle this thing, it will actually tell me that I have unhandled data in that specific place. I really fucking love that. Holy fuck. This is what I was missing when I was playing with this language. This is what I needed. Holy shit. Okay, that's pretty cool. So, you see, it doesn't matter how shitty your program is, how shitty your code is, it produces a useful behavior, and that's what's matter at the end of the day, right? So, I'm just trying to justify my shitty code, right? So, okay. Everything seems to be working, everything seems to be working. So, So what do we have? Implement type checking for if with else, right? For if with else, and I'm going to push that right into the ribbon. Okay, gun. Okay, gun. So now let's try to do the same thing for while. Arctun. Пять thank you so much for 5 Twitch Prime. Thank you so much, and welcome back to our 5 club. I already handle command line arguments. Yes, I do in fact already handle command line arguments. So in the test folder there's an argv example, and this is how we do that. So there is 2 additional intrinsics called argv and argc, and through them you can handle command line arguments. So I can even show you. So here is the argv program, foo bar buzz, and if you run it, as you can see, it prints the arguments that you provide back, and it's written in Porth. Right. So we do handle all of that. So I really recommend to check the tests folder just to see what kind of features the language supports. Like I think we have test cases for like all of the language features, I'm pretty sure. So yeah, we don't have tests for failed type checks though, but we are about to add them, right? I think we're gonna add them at some point. So basically I want to keep like a full suite of tests that I can then use for like after I rewrote Porth in itself, right? Because I can quickly check if I re-implemented everything. Cyberdyne, yeah. Thank you so much for 7 months of Twitch Prime subscription. Thank you, and welcome to Epic 5 Head Club. Epic 5 Head Club. All right. 5 means 5 in Russian, if you didn't know, if you didn't guess. As far as I know, it's the same in pretty much all of the Slavic languages. Numbers are pretty much the same in all of the Slavic languages. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? It's pretty much the same, right? So there's some deviations throughout the history, like in different languages, but apart from that, Baskij, I hope I pronounced your nickname correctly. Thank you so much for Twitch Prime, and welcome to Epic 5 Head Club. Oh, I know Slavic lang now. Yeah, you do. All right. So let's see. Right, so I enabled while loops, right? I enabled while loops, and let's try to run the while loops. What is it called? Control flow, right? Control flow. And of course I didn't enable the static type checks, and it is failing in do. Okay, this one is rather interesting. Let's go back to the drawing board. So this is basically what we have in here, right? When we're doing the loops. So when we're computing, we reach a particular state, and then we need to check a condition. Condition can modify right now the state of the stack arbitrarily. In fact, it would be more correct to write condition like this, right? So condition essentially modifies the stack to a new, completely new state, right? And what we need to check, I think, is that after the end of the condition, right, we end up with a single boolean on the stack, with a single boolean in the stack, after consumption of which we end up at the state S3, right? So that's basically what we need to type check in here. So while we'll save the current state of the stack, then we type check the condition, then we check that we have a boolean on top of the stack when we reach the do, we remove the boolean, and then we check again. Do we have the same stack? If we do, we continue type checking in here, right? So, and how do we type check the body? I suppose after evaluating a single iteration, the state of the stack has to be the same as before the loop itself, right? So it also has to be S3. So we check that we are S3 in 2 points, here after the condition and here as well. Maybe it would be even better to actually do it like this. So we check after we perform the do. Right, so here is the condition, we consume the boolean and check if it's S3 in here and at the end of the iteration. So in at the beginning of the iteration it has to be S3, and at the end of the iteration it has to be S3. You can underflow the S3, you can remove elements from S3, you can add more, but at the end of the stack it has to be the same, right? Otherwise you have something fishy in here. So this is the idea, essentially. This is the idea. And what's interesting is that this is roughly how WebAssembly is type checking their code, right? So this entire type checking system is actually very much inspired by the WebAssembly verification step. So if you never heard how WebAssembly verifies their code before executing, I really recommend to check out this particular article. I'm going to put this article in the chat, and also it's going to be in the description. Like, I really recommend to read this article if you're interested in how, like, the the details of how WebAssembly works. So this entire type checking system is actually inspired by this article. So I really like it because it makes a lot of sense. All right. Okay, so when we encounter while, I suppose what we have to do, we have to just put a block stack. We have to append copy stack OP type. Right, so there we go. Do we have to do anything else? I don't think so. We encountered while and we just saved the current stuff. Okay. After that, when we encounter do, right? When we encounter do, we have to check that we have enough arguments to like do the condition. Essentially, it's going to be the same as if. I suppose I can even copy paste this entire thing from if, right? Because it's going to be the same type checking. Right, so not enough arguments, invalid arguments for the while do condition, expected boolean. Cool. So after that, I need to extract the block, right? I need to extract the block. So here's a stack snapshot, and again, we expect the block in here to be while, right? So this is going to be OP type, and this one has to be while. Otherwise, there's some bug in the compilation step. And what we have to do in here, we have to compare the current state of the stack with the expected, right? So this is expected stack. And this code is pretty much the same as in here. So we stripping off the tokens because they should not affect anything. And if something went wrong, right? If expected types are not equal to the actual types, right? If they're not equal, we have to throw an error. And what exactly should we throw in there? What exactly should we throw in there? I feel like I need to actually extract those things into separate like helper function for reporting errors, but I'm too lazy right now, I'm sorry. So all of that code is going to be rewritten anyway. Okay, while do condition is not allowed to alter the types of the arguments on the data stack, right? So this is the first check that we do in here. All right, and after we checked this entire stuff, we have to put the current state of the stack back for checking the body, right? For checking the body. So for checking the body, and I suppose that is pretty much it. And let me see. So now it fails at, okay, so it fails at the end. There we go. This is actually perfect. So when we reached this assert, essentially what we're doing, we're type checking already here, right? We're already type checking here. And in here, there's nothing special. We just need to check yet again that we have the same types. What's interesting is that in all of these branches in here, we essentially have just equal expected or not expected, and the only thing that is different here is this error message. Maybe we can collapse this entire thing right completely, but I'm not sure. I don't know, we'll see, because maybe in the future we're going to introduce some blocks that actually differ from this behavior, so I don't really want to, you know, compress things before it's like absolutely clear that it has to be compressed, you see? So because we may introduce new blocks that, you know, will differ in this behavior, so it's better not to compress. So do you have something in mind that this programming language will be used for? Yes, it will be used for creating software, right? So for developing programs, that's what it's going to be used for, because it's a programming language. All right. So, so we have a while do condition, right, so I'm gonna actually copy paste this entire thing. All right. While do body is not allowed to alter the types of the arguments on this stack. Okay, that is perfect. And I think we successfully implemented. Okay, so we have unhandled data on the stack. Really? Do we though? We fucking do. Where is the unhandled data on the stack in here? You see, we pushed 10, and on each iteration we're just like duplicating and checking it. But then at the end of the loop, we didn't get rid of that 10, so we have to put a drop in here So the type checking just found a bug. Well, it was not really a bug, but I mean, it found like unhandled data on the stack, right? So yeah, we put the 10, we were constantly decrementing the 10, and after the loop, we forgot to just drop it, right? So we forgot to drop it. So that's pretty cool. So we're actually type checking shit. How about that? What's interesting is that if you forget to do the dupe, right, so one of the things I was constantly scared when developing this language is that, what if I get to duplicate this element, right, and the entire thing will go to shit? Well, now, this entire thing will not compile, because in that case, condition modifies the state of the stack, and that is not allowed, right? If I do something like this, that is also not, wow, what the fuck? Well, oh yeah, that's totally fine. Yeah, that's totally fine. So basically that was not modifying anything in the stack. Well, this is not a bug, right? So maybe that's exactly what I meant. Okay, so that's perfect. All right, we have a full type system, type checking system. So now we can pretty much just enable the type checking always, right? So I put the type checking behind the check flag because it was not finished. But now it's finished and we can just always enable it and go through all of our programs and fix those programs in the places where they don't type check. And also that will help us to test how our type checking works, right? Do we have any bugs in the type checking and so on and so forth, right? So I'm actually really proud of this thing. Holy fuck. I didn't expect this thing to be so useful. As far as I know, Porth doesn't do any of this shit. As far as I know, Porth is a dynamic language. It doesn't do any compile time type checking. So this thing is already like better than Porth. And I'm always, like, when I tried Porth, one of the things I was constantly scared is actually screwing up the arguments, right? But here I'm just like not afraid. Fearless well, it's not really fearless concurrency, but yeah, get the point. Anyways, so let's do the compilation of our nation. Pepper Pains. Implement type checking for while do loops. There we go. I'm going to push that right into the repo. Okay, so the next step is going to be getting rid of the minus check flag, right? So there's no minus check anymore. And let me just see. So here is the check. Might as well just remove this entire thing. So check. Okay. So now I'm gonna type check the Porth, right? Just to see if is there any places. Okay, so we always type check. First thing we do, we compile file into a program, right? Then we type check the program, and then we either simulate the intermediate representation or generate, you know, assembly code out of it. Right now, we have to always do that. Okay, everything seems to be fine. Now, let's go ahead and run all of the tests and see which tests are actually failing. Okay, so we already have failing tests, right? We already have failing tests, and the first failing test is a comments, right? So let's take a look at the comments. So it's going to be Porth, simulate, tests, comments. So where is it failing? Oh yeah, so primarily, yeah, we're gonna have primarily problems of not handled data on the stack. So this is actually a common mistake that people forget to drop the, you know, the return code out of this thing. In fact, maybe I can just go through this entire thing manually and get rid of all of them, but maybe not. So comments, comparison, okay, whatever, maybe not. So another test. Okay. Yeah, so majority of them is just like not being able to do drop. Right, so macro, let's go to the macros. Tests, macros. I really don't like that I cannot easily just go there. You know what I'm talking about? I really don't like that. So maybe one of the things I'm going to quickly do, in a test script, I'm going to just put an extra new line in here, right? So at least the Emacs will parse it correctly. You're making your own language? Yes, I am making my own language. Do exclamation mark project command and you'll get the source code of the language. What about the custom write macro that also drops? We can do that, but the write macro is supposed to be like a wrapper around syscalls. When you do write, you're actually calling syscall, and write may fail, and it will report an error via the return code. And you may want to report that. You may want to check what kind of return code is that and do appropriate actions. Do you develop languages professionally? No, I've never developed languages professionally in my entire life. All right, so let's go ahead and do that. So test by so expected. So and here what I want to do, maybe I want to just do new line, new line, new line, new line. And we always put new line in there. Okay, and we also have to do something like this. It's kind of a really weird way of doing that, but I'm just too lazy to split that into two separate prints. So yeah, it is what it is, and it isn't what it isn't. Okay, so let's actually rerun this one more time. One more time. So now it should be relatively easy for me to actually do that. Okay, so we have unhandled data. Oh yeah, that's actually very cool. The thing I forgot to do in here, I forgot to drop this entire thing. But interesting enough, I think I have to drop it twice. Right, unhandled data on the stack. Oh shit, I have an idea. So let's actually print how many unhandled things on the stack we have, right? A similar way when we have a type mismatch and we print what is expected and what is actual thing, we can also print what is the unhandled data on the stack and how many of these things we have to handle, right? I think it's also going to be very useful because here, I'm not sure, do I have to handle 2 of them or 1 of them? Because here I push 2, and I think I have to like drop 2, but I want to be 100% sure. So yeah, as you can see, we're already testing our type system and we're already finding errors in it, right? So type check, there we go. So unhandled data on the stack, and we can just print this thing in here, right? So, and what's gonna be the thing? So in here, we have to do something like stack, we have to do map, right? So we're actually popping it. I'm not sure if I want to just pop it. So I think I'm gonna just do 0. Yeah, so we get the first element on the stack. Is it really the first element? I think we have to... So I'm thinking we have to get the last element then. How do you get the last element? Right, how do you get the last element? So I think it's something like -1, if I remember correctly. So it's 1, 2, 3, and -1. Right, it is -1. Okay, that's cool. So this is going to be -1. That should not fail because we checked that. Then we take the token that was introduced, and I think we're reporting location properly. Right, we're reporting the location properly. All right, so let's take a look. Okay, so now as you can see, it fails unhandled data on the stack, and it actually, yeah, it actually prints a lot of shit in here. So there's like more than I expected. But yeah. Check less. Oh, okay, so if I do drop, right, drop, it will still fail, but now it will probably fail in a different place. So yeah, as you can see, it was actually very useful because I now know there's more places where I unhandled data. For example, here, right? So I definitely didn't handle any data in here. And there's probably another place where it needs to be handled, right? So we definitely need to do that. I can probably do something like drop, right? But I know that the easiest way to do that would be actually to put it in here. As a matter of fact, we already know that we can do something like this, right? So yeah, I really like how in concatenative languages, how in concatenative languages you naturally have like if as an expression, right? Like a ternary if. It's like naturally occurs. It's just like, it's kind of cool, right? So, yep. So, I don't like that. Okay. So is it failing now anywhere? Okay, so there's some errors in here. Unhandled data in a dead macro. Okay, so we have to drop this thing in here. What's the next stuff? So another one. And here. Okay, so there is a problem in here, but it expanded from strlen. Invalid argument load for... Oh, shit. This one is interesting, actually. Invalid argument. So invalid argument usually happens when like you expect one thing, like one type, like pointer, but you get an integer or something like that. I wonder why this shit happened. So let me see. Let's take a look at the load intrinsic. Porth.py. Load intrinsic. Type check. Intrinsic load. So what we expect in here is invalid argument type for load. We can print this thing in here. Let's actually just print it. What version of the Python are you using? Yeah, I'm using 2.7. I still didn't switch to 3 because I believe the third Python doesn't have any improvement over the second one. So, and I kind of prefer the first one. So it is what it is, and it isn't what it isn't. I'm sorry. So, all right. So in here we actually got int, but the question is where we got the int from, right? We got it from here. So we read. Oh shit! So in fact, this is true. We need to introduce typecasting. Believe it or not, boys and girls, we need to introduce typecasting. Because we read the pointer for the function from the memory, and we can only read integers from the memory. So we need a way to cast an integer to a pointer so the type checker shuts up. So that's all we need to do. So the time has come. The time has come to introduce the type checking, the casting. So how are we going to do that? So obviously it's going to be one of the operations, right? I'm not sure if it's going to be intrinsic though. Is it going to be an intrinsic? It could be just an intrinsic. Yeah. I'm just thinking how we're going to introduce that. Okay, so cast PTR, right? Cast PTR. So, and essentially cast PTR yeah, it's gonna simply like work at the type checking phase, but it's gonna be completely eliminated at compilation and so on and so forth, right? So it's gonna be completely ignored, if you know what I'm talking about. All right. So where exactly we failed? We failed at argv. All right. So this is gonna be Porth argv tests argv Porth. Okay, so here we have this situation in exhaustive intrinsic handling. Okay, 34. So how casting to pointer is going to look like? Let's actually call it something like cast PTR. Right. So literally, if you put this word in your code, the thing on the top of the stack is going to be interpreted as the pointer instead of the whatever it is there, right? So intrinsic cast ptr. Oh god, that looks ugly, I know, but it's a temporary code, right? So I'm trying to get to the rewriting the language in itself as quickly as possible, so that's why I'm taking these shortcuts, right? So in the future, when the language is finally rewritten in itself and we got rid of the Python, we're gonna try to make something better, right? So for now, it's gonna be like that. So unknown subcommand, okay, so that's cool. Let's try to simulate this thing. All right, so when we are simulating the thing, I'm actually surprised that the type checking didn't fail. Oh yeah, here is the type checking, so this is fine actually. So this is actually fine. This is actually fine. So where is the store? Okay, that's cool. Elif operand, op operand equal intrinsic. So what is it going to be called? Cast ptr, right? Cast ptr. So cast ptr will accept a single argument on the stack, right? It accepts a single argument on the stack. So if length of the stack is less than 1, not enough arguments for this operation, and we exit with 1. So then we take the type and we take the location. Actually, it's not a location anymore. It's a token, but whatever, right? And the cast doesn't really care what exactly in there. It really doesn't care. What it does, it basically appends back as data type ptr, right? So whatever was in the stack, it's basically reinterpreted as a pointer. So that's the point of this thing, right? It's just reinterpreted as a pointer. And that should type check. Okay, invalid argument type. Okay, so as you can see, now this thing tries to type check and it fails to type check. So the thing we have to do, we have to cast this entire thing to a pointer. So whatever we got from this thing, we're just casting it to the pointer. Okay, so when we have some unhandled data on the stack, and this is why. This is because we have arguments. Okay, so this is actually pretty cool. We pushed two things, argument pointer and argument counter, and we iterated through them, but we didn't clean them up at the at the end of the program. And here they are. Here we can see the things that we didn't clean up. So, and what we need to do in here, we just need to do drop, right? So to clean everything up. So here we push them, and here we drop them. So, okay, and we already properly type checked, right? So this entire thing type checked because we casted whatever we had to the pointer. So we have a simple casting system. So now it fails somewhere here. It fails at interpretation. That's pretty cool, right? So, and during the interpretation, I think we're gonna just simply ignore the casting, right? Elif op operand intrinsic cast ptr, and here we just ignore it, right? Ignore the type casting. It's only useful for type check program phase, right? There we go. Okay, so, and it seems to be working, and as you can see, if I do full bar pause, it is failing completely. You know why? Because one of the things we forgot to do, we forgot to increment the instruction pointer, of course. There we go, and now it is working. Now it is working. So let's try to compile this entire thing, and it's not going to compile because we didn't implement the compilation, right? We didn't implement the compilation of our nation. Oh, funny joke. It's not a joke. Right, elif op operand, right, op operand intrinsic cast ptr, and what are we doing here? I'm not sure. Maybe we can generate something in assembly, at least some sort of a comment, cast ptr like this, and then we're gonna say that again to do. not really to do, ignore, I don't know, whatever. So, and there we go, it seems to be working. So I also forgot to run this entire thing, and as you can see, there we go. So, it type checks. Let's continue testing. Right, I want to make all of the test cases type checkable. Right, so from now on, this is the type check model of the language, and anything else is basically not going to compile by this language. So this language is safe, right? So it's not really safe yet. So you still can screw up, but it's a little bit safer than it was before. Just a tiny bit safer. Not completely though, but a tiny bit safer. All of the test cases under the test folder type check. All of them. Isn't that cool? Isn't that cool? I think it's pretty freaking cool. And yesu kawaii freaking desu. Okay. Make all of the test cases type check. There we go, I'm going to push that right to the repo. But we have more than just test cases. More than just test cases. We also have examples, right? So let's try to run this entire stuff on the examples, right? So we're going to do run and examples. So do we have everything that type checks? Okay, so as you can see, not all of the examples type check, right? So let's take a look at some of the things that don't type check. Specifically, name program doesn't fully type check. So if you don't know, name is just a thing that introduced off screen, right? So let me take a look. Oh shit. Well, it doesn't compile anymore. I cannot even demonstrate you how it worked before, but essentially what it does, it asks you a name, you provide the name, and it says hello that name, right? So let's actually see where exactly it fails. Oh, this one is very interesting. So we handle the exit code of write, but we don't handle the exit code of exit. And it doesn't really make much sense because at the end in here, exit is not returnable. Right, so our type system is not even aware of such situation that some of these things may never return, so it always forces you to do drop. Okay, this is actually very interesting. So to do, think of the operations, think of type checking operations that never return, right? So basically like no exit situation. So because it's kind of stupid to do the drop in here, like why would you do that? But I don't know. By the same logic, maybe you don't have to like drop things at the end of the program too, but I don't know. Anyways. So what else do we have in here? What else? So here, invalid argument minus expected integer or pointer. Argument types 4 minus. So what's wrong in here? This is actually very interesting. So minus, you can only do minus for integers or pointers. I guess you can also do minus if it's a pointer and integer, and I didn't think about that. If it's integer and pointer, it doesn't make much sense, but if it's a pointer and integer, it does make sense. Isn't exit just a macro? It is macro, but it's a macro around syscall. So std, where is the macro exit? There we go. So it's a macro around syscall. So yeah. So drop, we don't put drop inside of macros because macros are meant to be like interfaces for the syscalls, and exit code is part of the interface of the syscall, and you may want to check whether it returns something or not. Though I think, does exit, specifically exit though, usually does it return anything? Though yeah, it's a good point. Exit usually doesn't return anything, and that means you can always just do something like this, right? Yeah, it's a good point, thank you. I didn't think about that, because specifically for exit, it doesn't make much sense to actually provide the exit code, because it never exits. Right. So let's actually see. Okay. So elseless is not allowed to modify. Okay, so, and is it gonna work now? Okay, so I think I now need to update how we type check the minus, right? So type check. Where is the type check the program and where is the minus? Okay, so here we expect both of these things to be either integer or to be pointer, right? So there is a second situation when type is equal to pointer and b type is equal to integer, right? So something like this, because you are allowed to subtract integer from pointer. I don't think you're allowed to subtract pointer from integer because then you will get something negative, but this entire thing will just result in a pointer, and I think it's a valid operation to do, so I think we may allow that. Hello, do you participate in a CPC? I participated in a CPC 10 years ago. I'm too old for this shit, I'm sorry. B-boomer clap? Feels old, man. Yeah, it is what it is. Is it ICPC season already? So, did St. Petersburg institution already won everyone? Itmo? What do you do professionally? Professionally, I'm shitposting on the internet. No joking, right? Like, my job is shitposting on the internet. That's what people pay me for. ICPC is a waste of time better than real programming. I think ICPC is as much of a waste of time as playing chess. I think it's the same level of wasting time, in my opinion. Alright, so maybe I want to actually print the types, right? So expected int, invalid argument step for minus. Let's take a look. Right, so I just want to print the current like stack types or something. Load. For the load, a type, b type. I just want to see what's there. How much is solving Rubik's Cube is a waste of time? As much as doing competitive programming, I think. So what I'm trying to say in here is that ICPC is an intellectual sport. How much of waste of time is sport? I don't know, everyone decides for themselves, I suppose. So, yeah. Okay, what I want you to do, name, so this is a name capacity. Okay, so we have name, and this is a pointer. Then I copy something over, then I sum this thing up, right? Then I sum this thing up. 2, 2, 2, then I do 1, and then I do minus. I think there is something wrong in here, right? I think I'm checking stuff in an incorrect order. Right, B is allowed to be, yeah, B is allowed to be pointer, and A is allowed to be integer. It's the other way around. Okay, that makes sense. So, and this is going to be like that, so. Okay, what else do we have in here? Okay, so, so far, the next thing that is failing is rule 110. Let's take a look. So, invalid argument for the if block condition. Oh, shit. Oh, shit. So essentially, what I do in here, I look at the row and I check, is the row 0 or 1? And I basically am abusing the fact that 0 is interpreted as false and 1 is interpreted as true. Right, so now since we have a type, like static type checking, I can't do that anymore. And I suppose I have to explicitly say 1 equal, though it is easy to fix that without modifying the compiler. So we don't really have to cast, right, people suggest to cast, but you don't have to, you can just compare it with 1. So doesn't matter. Type checking stops abuse, yes. Okay, go. It seems to be type checking. Okay, so now it fails somewhere else. Unhandled data on the stack for the sequence. Alright, so I basically forgot to drop this thing twice. I think we have to drop, right? And let me run sequence 100 specifically. Okay, so it seems to be working. Now I'm gonna run the rest of the things. Shouldn't cast boolean be faster than 1 equal? It should, but the optimization right now is not really, you know, part of the scope. So, okay. Oh, we have a reversed linked list. Yeah, I do remember that. So essentially, on our Discord server, we have a channel where we shitpost different code. Right, so it's called like something like dirty code. Right, and somebody suggested to implement a reverse linked list, and I implemented reverse linked list in Porth. And surprisingly, it's not that much code for a language without any structures, if you know what I'm talking about. Right, there's no way to define a structure, so I have to like do the layouting manually myself. I created a separate operation that reads the value field of the node structure and the previous field of the node structure and writes in there, and I basically created a bunch of macros to actually like access all of that and a bunch of operations that allocates the nodes and so on and so forth. So that was actually super fun. So I really recommend to check it out in the examples folder. It's called literally reverse linked list, and it works. Surprisingly, it actually fucking works. So yes. Okay, so, and it doesn't type check anymore for whatever reason, right? So let's see. So what do we have in here? Invalid argument type for the store 64. Interesting. So it comes from the push code. Ah, I see. This is because, all right, so we read the list and we copied this thing over. I suppose if we take a look at the list, right, so what does it store? It stores the pointer. So store. I suppose we're trying to store a pointer, but we can only store integers, right? We can only store integers. I think we should allow storing whatever you want, right? Let me actually quickly do that. All right, so this is going to be Porth pi. Porth pi. So store. I think it was 64, right? So it was 64. Store 64. Invalid arguments for the type. And in here, I'm going to do something like this. B type, A type. Okay. Maybe I'm going to even do it like this. Okay, so yeah, as you can see, both of them are pointers, right? Both of them are pointers. So I suppose one of the things I want to do is basically say that we don't care about A. A can be whatever, right? So maybe we can even say something like A or A type equal data type pointer, or for now we're only actually trying to store pointers, so I think it's going to be fine. Right, so we're going to implement like storing the booleans when we actually have an example that tries to store booleans. Right. So, and the next thing here, yeah, invalid argument to type integer. Oh, okay, so this one is interesting. So yeah, cast over. So this is where we push this thing and then we try to perform this thing. and then in here, when I do that, I'm trying to store the value, right? I'm storing, or am I? Yeah, well, I'm storing the value. So I'm just thinking, where do I have to perform the cast? Where do I have to perform the cast? So I swapped this thing, then I read something, right? I read something, and I suppose this is where I have to do the cast, or to the pointer. Hopefully this is where I have to do that. And I think I did it. I think it actually worked. All right, so this is where I have to do that. So I duplicated and I did cast pointer. All right, so there's another error in here, and it's the same one. Holy shit, this is so useful, actually. Right, so I explicitly, well, I mean, forcing to put casts everywhere is not particularly useful, but it's like, at least it shows the errors in the precise positions, which I didn't expect. I expected that it's gonna show errors in like all over the place, not in the place where it's needed, but it's actually pretty useful. I really like that. Okay, so now everything seems to be type checking, and let's run on the whole thing. So rule 110 seems to be working, so it's taking some time, and everything seems to be type checking. All right, so let's do a committee, and maybe even pushy. Make all the examples type checked, right? Make all of the examples type checked. So I'm not sure, do I want to enable the type checking always? Because as we discovered recently, for some of the operations you do need to support like generic arguments, if you know what I'm talking about. So basically one argument has to be a pointer, but the second argument can be whatever. It could be either integer or pointer, and we don't really know all of the possible combinations. So because of that, maybe we want to allow the users to disable type checking, right? So maybe I'm going to actually introduce inversed flag. Essentially, by default, we didn't do type checking, and you had to enable it. Now it's going to be enabled, but you will be able to disable it, right? So something like that. So in case we, like, one of the type checking logic is incorrect, but you still want to compile your program, just you can disable type checking and it will be able to compile whatever you want. Right, unsafe. Yeah, we're gonna call this flag unsafe. Yes, this is perfect. Let me actually do that. So this is gonna be Porth. So name, where is it? Name. So print unsafe. Disable type checking. There we go. And in here we're gonna have something like unsafe. So this is gonna be false. And else if argv0 called unsafe, we'll have to remove that argument from the command line arguments, argv1, and we'll have to do unsafe true. So it's false and now it is true. Type check. If unsafe, if not unsafe, that means it's safe, that means it's going to be type checked. Type check if not unsafe, that means type check. There we go. So by default it's going to be type checking, but you'll be able to disable this entire thing if you want to. Okay, cool. Implement, introduce unsafe flag that disables type checking. All right. So let's try to run now the Euler problems, right? But we know that one of the problems is actually very slow on CPython, so we're going to use PyPy because it's a little bit faster. Okay. So we're doing problem 5. Problem 5 type checks. Problem 2. Okay, so problem 2 doesn't type check. So let's actually work with problem 2 now. So this is going to be problem 2. Unhandled data on the stack. So I suppose I forgot to do drop in here, or maybe just to drop, right? Okay, seems to be working. So let's take a look at the rest of them. Porth. Yes. Porth is my favorite language, of course. So problem 1 also doesn't type check. Problem 1, Porth. Porth. Invalid argument type for bore intrinsic, really? Of course. Oh, okay, so, fuck. We have only bitwise OR, but we don't have a logical OR. Well, I mean, we can enable that specifically for bore, right? So let me see. Oopsie doopsie, wacky wacky. So what is it called? Like bore, type checking. Bore to and int. Aha, I have an idea. If a type is int, well, shit. Fuck. Damn. Shit, fuck. Damn. What I want to do is basically, if it's boolean, right? If it's boolean, I want to just do boolean. There we go. But here I want to like repeat this problem, right? And I want you to get rid of the duplicate code, but now I have to duplicate error checking, which is dumb, right? Which is dumb. Shit, fuck, damn. Yeah, fuck. And so maybe if I duplicate this kind of stuff like so, it's gonna be fine. So it's actually less duplication if I duplicate. Quote that. It's less duplication if I duplicate. Alright, so is it gonna work? Is it gonna work now, yo? It is in fact working. It is in fact twerking. Okay. So they're pretty slow actually. Okay, so which one? It's the third one. Third one is not twerking. Problem 03, Porth. Use the duplication to destroy the duplication, yes. Okay, so we have unhandled data. So essentially we have the answer on the top of the stack, I presume. But then we have additional thing that is not needed anymore, so which we also have to drop. Okay, because we pushed 2 things on the stack. Makes sense. In fact, makes sense. Alright. If you self-host the compiler, will the P in Porth stands for Porth? Yes. Porth is like fourth, but in Porth. Alright, everything type checks. Will you look at that? Everything, in fact, type checks. To make all the Euler solutions type check. There we go. I'm going to push that right into the repo, and I'm going to make a pull request to run all of that on CI. How about that? Type check control flow. Finally, we have pretty cool feature in this language. Right, so we have an actual type checking. Holy fuck, I really like that. Yeah, so now I'm not afraid to do things in this language, and it's actually quite pleasant. Maybe you should implement something in this language, like super quick, to test out the the type system. I remember I had like a list of things to implement, and I wonder like what can I implement? Not sure. I think I'm not going to implement anything right now because I'm registering for 2 hours and it's just like too much for me. All right, so let's wait for the continuous integration to finish its thing. So does anyone have any questions while CI is running? Does anyone code ASP.NET Core? No, it's a dead technology. Nobody programs in that, I'm sorry. Porth is the next ASP.NET. Porth is very fun to use, to be fair. Oh, you're already using it? I'm really glad that it's fun to use. Do you plan to multi-thread the tests? Well, when we have a lot of tests, to the point when it's needed, then yes. Then I'm going to multi-thread the tests, but I don't think it's a priority right now. I don't think so. No, I don't think so. Any other questions maybe about what we're doing right now? Oh, by the way, is it Hacktoberfest already? I think it is Hacktoberfest already. Is it going to be as much of a shit show as the last year? I hope so. Last year was fun, actually. What is planned before self-hosting procedures? I actually plan to implement a lot of additional features while doing self-hosting. And I think procedures are going to be implemented as part of self-hosting if they are actually needed. So that's going to be the plan. What is the name of the language? It's called Porth. You can find the source code of the language by doing !mac project command. Slight off-top question. Should I fix the double CI runs again as I did on some other repos? I don't know. I don't really accept any contributions right now to this project because I'm actively experimenting and your contributions likely to become very stale. But I suppose for CI it's fine, so I guess go ahead and submit the CI thing. Okay, so it's not going to be as much of a shit show because it's opt-in from the beginning. So you'll develop Python compiler while developing self-hosted compiler. I'm going to develop Porth compiler while developing self-hosted compiler, not really Python compiler. Oh, by Python compiler, you mean the Python version of Porth? Yes, yeah. So the idea is going to be that I'm going to be implementing them in parallel, right? So I'm going to start re-implementing Porth in Porth, and if I miss some features, I'm going to carefully evaluate those features, then I'm going to implement them in Python version, and then eventually implement them in Porth version, right? So it's going to be sort of like a self-referential process, right? So, and at some point when Porth become powerful enough, we'll be able to get rid of the Python. That's the plan, at least. I've never done it before. So, yeah. So next stream is self-hosting, hopefully. That's the plan, at least. I'm gonna do a little bit of a cleanup, and if during the cleanup I'll find something that needs to be implemented, it could be implemented on the stream, I'll do that before self-hosting. But if I don't find anything and we're pretty much ready for self-hosting, on the next stream we're gonna start self-hosting. Yes. The concept that a language can compile, interpret itself is so cool. Isn't that what PyPy is doing? Not undermine your statement, by the way, it is in fact cool, but I'm not the only one who came up with that concept, definitely. So, and PyPy in fact is what, people were doing before. So PyPy, as far as I know, is implemented not really in Python, right? It's implemented in our Python. So I might be wrong. Sorry if it was too loud. I might be wrong, So correct me if I am. Please correct me if I'm wrong, but I think the interpretation / compilation scheme of our Python is the following, right? So PyPy, so we have a PyPy, which is interpreter, right? It is interpreter, and it is written in something that is called our Python, right? Right, our Python. So PyPy is implemented in our Python. Our Python is a restricted subset of Python. It is very restricted to the point that it is translatable to C. Right. So we can actually say something like this. So our Python is, I think it is translated to C. I think, I might be wrong, but I think it's translated to C. Please correct me if I'm wrong. It's translated to C, and that C program is PyPy. Right. And the script that translates our Python to C for this thing to become PyPy is written in Python, in full Python. And that script is interpretable by PyPy because PyPy is an interpreter of a full Python. Right. And basically this is where you have this sort of loop. Right. So PyPy is implemented in our Python, which is translatable to C. Right. So you implement interpreter in Python, and the thing that translates our Python to C is written in Python, and you have this sort of loop. So I think this is how it goes. Again, I might be wrong. I briefly looked into how PyPy is implemented, but I think this is how it works. So if we have any PyPy developers in the chat, please correct me. So if you get an interpreter in our Python, you get a JIT compiler for your own language for free. Ah, okay, that's pretty cool. So it's more than just a language. It's also like a system that enables like JIT compilation for you as well. All right. Again, I might be wrong. Not saying that this is how it is. This is how I understand it. So. All right, so I guess that's it for today. Today was a very productive stream. I really enjoyed it. I hope you enjoyed it as well. Thanks everyone who's watching me right now. I really appreciate it. Thank you for all of the support, for all of the subscriptions and beats and stuff like that. It is very much appreciated. And I see you on the next stream. Hopefully on the next stream, not necessarily on the next YouTube video, but on the next stream, on the next live stream, hopefully we'll start doing the self-hosted. We're not going to do that within a single stream, of course, but we're going to start. We're going to prepare everything, right? We're going to create porth.porth file, right? So right now we have porth.py. And we're going to create porth.porth file, which is going to be like, you know, like a partial rewrite of porth.py into porth. And we're going to slowly and painfully rewrite this entire thing in itself. All right. So thanks everyone for watching. I gotta go. I'm going to go eat something because I'm super hungry. Super hungry. Thanks everyone. Love you. Yeah.